Hello everyone, my name is Sergio Pereira. I work as a solutions architect for Azure Consulting, and I'll be running a demo on Visual Studio Team Services, continuous delivery with release management. So I'll be covering the following topics. I'll briefly talk about builds and continuous integration. We'll talk about how does release management integrate with Azure. It's worth to mention that release management works both with on-premise and cloud environments, but the purpose of this demo is to focus on cloud environments. We'll talk about release environments and configuration variables. What can we do with them? We have shared and release specific variables. This is a very powerful feature. We'll also talk about deployment conditions, triggers, and approval workflows. Okay, so just to give some context on builds and why do I need to briefly explain and run a quick demo on how builds work with Visual Studio Team Services. Continuous integration is one of the most important pieces in development operations. And as such, release management works really well with it. Our automated build will produce the packages release management needs to deploy the app. So let's have a quick run on my build definition. I've created a build definition that basically creates a package and run some tests. I'll be creating a physical package so that release management can work with it and deploy the solution. This build is set to be triggered in continuous integration so that every time we check in code from Visual Studio, this build will be executed. Okay, so let's now talk about Azure Service Endpoints. This is basically the way Visual Studio Team Services release management integrates with Azure. So it's basically a link that allows the release management to use Azure as a service. Let's just jump into our services configuration. You can see in here that I've created a service endpoint, and we can see in here that we can set this Azure service endpoint by either using credentials, where the user provides the Azure subscription ID, subscription name, and the username and password. And we can also use certificate-based authentication. This can easily be downloaded from within the Azure portal. and basically then you just paste all of the settings and the certificate that comes in the XML downloaded from the Azure portal. Okay, so next topic is what are release definitions? So in release definitions, we have what we call environments. So basically you can create different environments throughout your release pipeline. Usually environments like dev, staging, and production. We also have tasks, which release management supports a number of different tasks to be executed in the release pipeline. This is a very powerful feature that basically allows you to have full control over your release pipeline prior to and on the deployment phase itself. We also have something called artifacts. Basically, we need to use a build source for our releases, and this is why I previously created a build definition so that we can use it further down the line. And as mentioned previously, we can manage release variables across multiple release environments and also have shared configuration variables across the different environments. And pretty much as we can do with the build definitions in continuous integration, we can automate release executions, and we can set them manually or at a given time. So let's jump into our demo. We jump into our release tab from within the default dashboard, the main dashboard. Go into release, and basically I've created a new release definition. So as mentioned before, each release definition can have a set of multiple environments, artifacts, configurations, triggers, and so on. But basically, we can create a number of different environments. For the sake of this demo, I've created these three. We'll jump into all of them in detail later on. But say for this demo environment, we can create a number of tasks that will be executed throughout our deployment process. Usually you will find you will have to implement or add a number of different tasks in order to fulfill all your specific requirements. We can see that we can run a number of different tasks. We can run build tasks prior to deployment from different providers. We can run batch scripts, PowerShell scripts. We can also run unit tests prior to the usually prior to deployment, but worth to mention that usually unit tests run within the build, so it's on a previous stage, but for the sake of this demo, I just added two Visual Studio Test runs so that we can see the output. Usually what we would do would be to add cloud-based web performance tests, functional tests, coded UI tests, load tests after the deployment is accomplished to make sure that the deployment was fully successful and that you can approve it. You can also run packages, create your own packages prior to the deployment. And finally, you can deploy onto Azure or on-premise machines. In this case, I've used Azure Web App Deployment because I just want to deploy a web app onto Azure. So on the test, I'm basically running my unit test from my test project, and after that I'll be deploying my solution onto Azure. So if we look into this Azure subscription, this is exactly what I've explained before. Let's just briefly jump back into this. This is where basically I've set my Azure service endpoint so that release management knows how to and where to basically deploy the solution. Can give the web app just a name. What's the location where that web app will be located? Can use slots if you need to as well. Usually it would be used in to basically replace a production slot and have zero downtime between different releases. This is where you set what's the web deploy package. This will be basically using the deploy package that has been created by our continuous integration build. I'll jump back into it. And these are some of the additional arguments we can use on the release pipeline onto our automatic provisioning onto Azure. We'll jump into this as well. And after the deployment has been done and executed, I'll be running tests again. As I said, in real life, you would want to add your coded UI tests, performance tests, and so on after the deployment is complete. So for each environment, you can also assign improvers, set your agent queue, which is basically your agent that executes a specific deployment, configuration variables, and deployment conditions. You can also clone environments and save them as template to create basically a standard deployment environment. We'll jump in detail into some of these items later on. So just to explain what artifacts are and why do we need them. Basically, I've set up an artifact which tells release management which build to use. So where and how do the packages get created, the packages we need to basically deploy onto our release environment. In this case, I've created my build definition, and release management is bound to this build definition so that it knows exactly what the package is and where does it come from. So on this configuration, you can basically create a number of different configuration variables. These variables are shared across the different environments, and so they can be used as such. You can, for example, create a new, say, database name shared, and save this, and then I can use this shared configuration in a number of different artifacts, such as the Azure PowerShell arguments being used under the hood by this Azure Web App deployment, which we will cover later on. Basically, I can come in here and use that variable as a token. I can also use these variables, for example, in a PowerShell task where in a real life scenario I will have to set different configuration variables, web config parameters, in a shared way, basically. So basically, this configurations allow us to centralize configurations across different environments, and if we need to, we can apply those variables onto our release pipeline. So on the environment triggers, we can specify that we want continuous deployment and that we want to create a new release every time a new artifact version is available. This means that basically every time code is checked in from within Visual Studio, our continuous integration build will be executed, and if that build is successful, after that build runs and if there are any tests bound to it, if all the tests pass, if all the conditions pass, our release pipeline will be triggered by the build that has been treated by continuous integration. We will cover this in the demo. Let's now talk about release specific configuration variables. In this case, I'm in my dev environment. I have a number of predefined variables in here. I can basically delete them all, redo them again if needed. I can basically hide all my passwords or all my values if I need to. And pretty much the same way as shared configuration variables work, release specific variables work with as tokens, and they can also be used in the release pipeline or prior to the release deployment. In real life, you'll also be using this as input variables for your PowerShell scripts that would basically deploy a database, or that would transform your web configs, or just run or override any configurations you might have in web config. And so these variables are very useful, and they, alongside with global configuration variables, you can pretty much set everything you need across multiple environments in a single place, and you can use those variables everywhere from within the release pipeline. For example, this database name variable was being used previously in this additional arguments for our release pipeline, because under the hood, this task, Azure Web App Deployment, uses PowerShell to basically provision a new application onto Azure by using the command publish-azure website project. So basically, this additional arguments will be used by this Azure PowerShell commandlet in order to be able to deploy the solution onto the web app. If you come from on-premise deployments, you can think of this Azure Web App deployment as something close to MSBL deployments, even though they don't work exactly the same way, but they can use exactly the same packages produced by MSBL. As such, these are just some additional arguments we can use exactly when the application is being deployed onto Azure. As mentioned before, in real life, you would definitely need to have at least a PowerShell task in order to basically allow you to extend the release pipeline, and using the power of all the variables that can be shared across these multiple tasks, either coming from these global configuration variables or release specific variables. So now I'll be running a demo where basically I will show this build, test, deploy, test workflow, starting with my code check-in, checking my build pipeline, the automated trigger, as I've set it up previously. It will kick off after I check in my code from Visual Studio. We'll have a look at the live execution. We will see a build and the report, and we will jump into our deployment phase and see how it all binds together. So if I jump into my Visual Studio, I'm just changing one of my views, and I'll be checking in my code. This is all in real time. So if I jump into my builds, see if I have something in the queue. I do. This build has been triggered by the check-in just a few seconds ago. It's basically getting all the required files to build the solution. And then we will be running tests against the solution. And finally, it will be copying files to staging the environment, staging physical location, and finally, we will be publishing, creating our build package. So, get back into the builds. See, it has been successful. We can see that we've executed some tests, and we can see here the test results. And we can also see that right now we have a deployment for our dev environment that is in progress. We'll jump into it in a second. You can also see in more detail which tests have been executed. It's important to mention that if in this configuration, if there's any test that fails, the build will fail, and as such the release, the deployments will not be triggered by this continuous integration. So the continuous deployment will hold. So if you jump into our release, I have a number of dummy releases in here, and we can see, oh, okay, it has failed. Let's see what the problem is. And we can see that for this particular environment, this build as failed. So we can at any moment check a number of our configurations, see if everything is as it's supposed to be, but the most important thing for troubleshooting is to head on to our logs and into our release pipeline. We'll jump into this approval later on. So on the deployment phase, the deployment has been initialized successfully. We downloaded the artifacts from our build staging environment, and we try to run some tests based on just jump back in a second so you can see after we copy all the files from our staging environment in order to run the deployment, we kick off tests from our test project based on this task execution pipeline. So if we go back, we will see that, okay, one of our tests, one of our asserts has failed, and as such the whole execution is halted. The pipeline hasn't even reached this phase or this last second test run. So we can see in here what has failed. We can filter by outcome. In this case, we can see all of them, but this release test method has failed. So what I'll do is I'll fix this test, and then we will see the application being deployed automatically. So if everything goes well. So I'll change this to lab test 2, and I will change my test method I was already expecting this, so now let's hope everything goes well. Let's fix test. Let's check in and let's see how this process goes now. So if I jump back into my builds, I will have another build on the queue. Yeah, just now, correct. It has been triggered straight away. You can always follow the execution pipeline in real time, which is very good for troubleshooting, and on top of it we have very detailed logs for the different stages, so that we can streamline any problems and sort them out. Okay, so this is almost finished. The build has been successful. You can see in here that this on the release, this release, this deployment is in progress for this particular environment. Dev, we also have staging and prod, which we'll get back in a few minutes. Jumping back onto the build just in a second. As I've mentioned before, from within this dashboard, you see that everything is intertwined. So continuous integration, continuous deployment are bound together. So you can see that this build, as it was successful, as it executed all the test runs successfully, it kicked off automatically a deployment onto our dev environment. And we can see in real time that it's in progress. Okay, great. So it seems that now everything went as expected. This release has been successful. We can see that we've executed 2 test runs. I've called this test execution prior to deployment so that we know that this has been executed prior to deployment. And this, in this case, just running the exact same unit tests, but in real life you would be running your code UI tests, your performance tests, and so on and so forth after the deployment has been completed. The tests are passing here, and you see that basically that it has executed the exact same tests twice, just for the sake of this demo. Once again, it has executed tests, it has deployed the solution, and it has executed tests again. So let's see now if the application has been successfully deployed. Okay, this is exactly what I was looking for. So the deployment has been successful and everything seems to have gone pretty well, which is great news. So we can see from this demo that Visual Studio Team Services Release Management works pretty well with Azure, and it is pretty much bound, or it should be bound, with continuous integration and build definitions from the Visual Studio Team Services as well, so that we can have a full end-to-end continuous deployment that is triggered from a check-in. Worth to mention, all of this is automated and it all has been kicked off by a check-in. Naturally, this is all heavily customizable, but for the sake of this demo, and in many cases it's very useful to have this continuous deployment, mostly in dev environments and staging environments, and naturally in production environments it heavily depends on your company policies. But this is where approvals are very useful. So we'll jump into approvals in a second. So before we talk about the approval mechanism, the approval workflow, let me briefly talk about release creation and manual deployment. So in case we want to create a release that hasn't been created automatically by the continuous integration, continuous deployment workflow previously explained, we can create a release from here, can give it a description, and based on the build artifact we've previously set for this release pipeline, we can select build version. So basically we can, if we want to, we can create a release for a previous version of an application to a different environment, say a test environment or so. We can also set from within this window what are the rules for automated deployments. So in this case, for dev environment, we can set that the automated deployment is set after the release creation, and for staging, we can set, or right now it's set that the deployment is successful after deployment to that environment. We can also jump into this release, for example, and for these 3 environments I've previously created, we can manually deploy, but this depends on the configuration for a particular environment. So in this case, both dev and staging environments are set for automated deployment, so that means that you cannot manually deploy it. This is because we have set deployment conditions. In this case, for dev environment, we say deployment condition is after the release is created, the deployment is automatically created. For the staging environment, you can jump into deployment conditions and we see that the rule that is set is after successfully deploying to another environment, in this case to dev, this deployment to staging will be automatically executed. Whereas for prod environment, we don't have any deployment conditions, no automated deployments. So this means that in order to deploy to this production environment, we have to use this feature for manually deploying. If we click deploy, we will basically deploy this solution onto our production environment. Having said this, let's now jump into approval workflows. So what I've said previously was that for dev environment there's no approval workflow, and what this UI, what this progress bar tells us is that the release to staging is pending a pre-deployment approval. So let's see how can we actually set this and how can we actually trigger it. So what I'll do now is, for the dev environment, I will set an approval for pre-deployment, where I will specify that this user will have to approve this deployment prior to its deployment, and that this same user will have to approve the deployment after it has been deployed. This can be used as a trigger for other environments. In this case, as I said previously, in the staging environment, we have deployment conditions that say that the automatic trigger for deployment is after a successful deployment on another environment, which in this case is dev. So once we have pre-approval, precondition approvals, pre-deployment approvals, and post-deployment approvals for the dev environment, the staging environment approval workflow will kick in. So what I have now for the staging environment is pretty much the same as for the dev environment, just for demo purposes. So this user, or we can specify a number of users, will have to approve this deployment prior to its deployment. And this user will also have to approve this deployment after it has been successfully deployed. We can see that we can add a number of users and just say that, okay, if there's any one user that approves this deployment for pre-deployment, you can, the approval is done. Otherwise, all the users will have to approve this before the deployment is automatically triggered. The same happens for post-deployment approvals. As you can see, it's pretty much the same set of options. This gives us a good level of control over who and when a deployment has to be approved in order for it to kick off. And we can also see that the approval mechanism is throughout the different environments. So I'll also set deployment conditions for production, and I'll specify that after the staging environment has been successfully deployed, the deployment will kick off automatically on production. But you will need a specific number of users to approve it. In real life, you would want at least 2 owners to pre-approve a deployment. And for post-deployment, we'll keep it automatic, so no workflow approval in here. So let's jump into the demo. Let's jump into Visual Studio. Let's change our view. Lab test 3. Let's check in our code. And let's see and follow this continuous integration, continuous deployment workflow. So right now we are on the build phase. We're storing and get packages. Solution is being built by MS build. We will then be testing the assemblies for our unit tests. Copying files to the staging environment, and build succeeded. So let's jump back into our build. It has been completed, and we see now that the deployment into that environment is in progress. So jumping into our releases, we see now that we have a new release that has been created, and this deployment is in progress into our dev environment. See what's going on under the hood. And so we can see the deployment has been successful. From this release window, we can see that there's a pre-deployment approval pending for staging environment to be deployed. If we jump back into our these definitions and our environments, we can see in the staging environment that we have assigned approvers for pre-deployment and post-deployment. So as I am an admin in Visual Studio Team Services, I can override this pre-deployment approval, or the user or the users, all the users that were set as approvers for this pre-deployment will receive an email, and they will have to click a link on that email, which will take them to Visual Studio Team Services, the release window, and they can approve a particular deployment. So depending on the rules, as I've mentioned previously, it might just be that it's enough for one of the users, one of the approvers to approve, or it might just be that all the users all the approvers will have to approve either pre-deployment or post-deployment for it to be executed. So, on the purpose of this demo, I'll just override this pre-deployment approval. And I will approve. So right now we see in real time that the staging environment for release number 17 is in progress. And we can see what's going on in real time for the staging environment. Right now, the website is being deployed to Azure. So we'll see in Azure, we'll see a new app service being created automatically. Here it is, ALM App Lab Staging, and it has been created. So now we have a post-deployment approval, which, as previously configured, it's a precondition for deployment onto production. So let's override this post-deployment approval. And we see that staging has succeeded. Okay, I'd be expecting the production approval workflow to kick in, but for some reason it's not. So let's jump back into our environment settings for production for this particular release, and let's see what's going on. Okay, for some reason pre-deployment approvals and post-deployment approvals haven't been saved by me previously, and I guess that this also happened in dev environment, and hence there was no pre-deployment or post-deployment approval. Not a big deal. In fact, yes, this is why there is no automatic triggering or no approval workflow being kicked in for the production environment, because I didn't save these settings. So as it stands, as this is part of release number 17, we cannot change these deployment conditions within this release, but we can jump into our production environment configuration apart from the release itself and see that I've already set deployment conditions correctly, and there are still no approvals. So okay, I'll add myself in here, and I'll leave the post-deployment approvals. So deployment conditions seem to be okay after successful deployment on another environment, and approvals, pre-deployment approval myself. Okay, so you have to make sure you hit save, which I'm sure that I didn't click it previously, and that's why I didn't. The configurations didn't get saved. So if we jump back into our release number 17, we don't actually have to do all of this again. We can deploy onto production, because for this particular release, the production deployment conditions were not set at all. So, and no approvals were set as well. So I would set the approval only for this, for the sake of this release. This is very important to mention once again. So you have release level configurations that basically can override some settings, and then overall environment configurations. So I'll leave this approval and I will save and I will deploy onto production. As you can see in here, it also gets the change set and the commits that I've done for this particular build, just done it a few minutes ago, and we have a pre-deployment approval and no post-deployment approval. So let's go on and deploy. As we can see here, straight away, there's one pre-deployment approval. And I'll override this again. We can also defer a particular deployment to a moment in time. Say, for example, we want to deploy this after work hours in production environment. So you can easily set it to, say, midnight or so in a weekend. For the time being, I'll be basically approving it now, so deployment will kick off for production. You can see in real time what's going on in the release pipeline. So pre-deployment approval, it's right now deploying. Download all the artifacts to a temporary folder, and it's now deploying the solution onto Azure. And then finally it will run tests. Let's just see why these are the only tests being executed. So deployment and execute test from my unit test project. As I said previously, these tests are set per environment. So on the dev environment, I actually have 3 tasks. On the staging in prod, I only have 2 tasks. Okay, so it has succeeded. You can see in here, it has succeeded onto dev, staging, and production. If we jump back into our Azure portal and refresh, we'll have an ALM App Lab dev environment, ALM App Lab staging environment, and ALM App Lab prod. So if let me just see if this is up and running. It should be. Yep, and we're all set. So from this summary tab, we can have an overall picture of our current status. We see that deployment has been succeeded for all the 3 environments. We can see all the test results across all the environments. We can check a detailed report for each environment. We can also see what are change sets, basically the check-ins that were done against this particular build and against this particular release in this case, which work items, if any. I didn't add any work item, even though in real life it's good practice for traceability purposes to check in always against a particular work item. You can again see our test results. You can filter by failed, passed, and all, and we can once again see detailed logs of all the steps for all the different environments. This is the overall picture of all our releases and all the deployments for different environments in one single panel, and worth to mention once again that all of this is updated in real time, so it's very easy to keep track of the current status of a particular deployment. To make sure we've covered everything, approval workflow mechanism, support for multiple approvers, pre-deployment, post-deployment approvals, and our demo. So it's time to wrap up. The purpose of this demo was to talk about release management for Visual Studio Team Services and explain how integration, automation, and extensibility are the most powerful tools from within release management, and how easy it is to streamline your continuous delivery process in your organization. So we've seen that Visual Studio Team Services release management works both with on-premise and cloud environments, even though the focus was heavily on Azure. We've seen that integration with Azure drastically improves infrastructure management and operation support while delivering fully scalable systems. We've talked about infrastructure as code, the way it works under the hood with Azure, automatic provisioning, and all all the Azure enablements in terms of infrastructure management and scalability and tools for support zero downtime, like slots, and all the power that comes within Azure. So that's what this integration provides: full Azure integration. We've also seen that the release pipeline offers a great deal of customization and extensibility through the use of different tasks and different task types. So we can basically say create a package as part of the release pipeline, or run some code.ui tests, or run our own PowerShell or shell script files. And naturally, that's the extent of using all of these different tools. You can heavily extend how the release management pipeline works. We also covered global and environmental variables. We've seen how they can consolidate configuration management across multiple environments. One of the most common uses for this configuration management is through the use of PowerShell, for example, where you would have full access to all the variables you've set, and so you can streamline different configurations for different release environments from one single place without the hassle of providing or managing 2 different or 3 different places where you would manage all of those configurations through the use of, say, web config transforms or parameter files and all of those. We talked about approval workflows and how they stimulate collaboration, transparency, and corporate production release strategies. Naturally, the use of approval workflows is very important because it ensures that the right people, the actual environment owners, the stakeholders, and the business knows exactly when a particular release is deployed and on which environment, so they can easily manage all of this release management process. And finally, we've covered real-time release progress, reporting, and detailed logging across all the steps in a release management pipeline workflow. They are very useful tools for troubleshooting, for status updates, and mostly on the status updates, they definitely promote collaboration between business, development, and operations, as there's one single place where everyone can know exactly what's the status of a particular environment at a given stage. It was great to run this demo. We hope it can help you implement your own continuous delivery by using Visual Studio Team Services. Get in touch with us. give us some feedback. And also, if you have any questions, you can reach me on Twitter, and you can join us on our TFS ALM group for great VSTS and TFS features and updates. Thank you all for your time.